Halogenoalkanes with ammonia forms amines. So we want to warm a halogenoalkane with excess ethanolic ammonia. This just means ammonia dissolved in ethanol and a lot of it, excess, and ammonia swaps place with the halogen. Again, it's an example of a nucleophilic substitution reaction. I don't know why I'm saying again, but in the future videos I'll be going through the other types of nucleophilic substitution reaction, and you'll see there's a lot of them. So a halogenoalkane, so let's go through the mechanism now. Halogenoalkane, C H H H H H H. Actually, let's get rid of this and put this as the bromine. So we've got ammonia with the lone pair H NH3. This is delta positive, this is delta negative. The lone pair of electrons are going to attack the carbon and it's going to break the bond. So the CBr bond. So now we need ethanol, excess ethanolic ammonia. Now what happens is we get, to this stage. Well, a lot of students would probably get to the stage where the nitrogen is now positive, and you've obviously got the lone pair of electrons on the bromine negative. So exactly the same as a normal nucleophilic substitution reaction. However, now the ammonia is going to remove a hydrogen from the NH3, forming an amine and an ammonium ion, which is NH4 plus. So let's see how that works. This is the first part, this is the second part. So now we've got this plus H and H. Now ammonia, again, with lone pair of electrons, 3 hydrogens attached to it, is now going to remove a hydrogen from NH3, and now because it removed the hydrogen, got extra hydrogen, it wants to now attack the nitrogen. The nitrogen is positive, and now we get ammonium ion, NH4 plus. So first things first, we can just write that down. And what happens here now is now the nitrogen has a lone pair of electrons, basically transferred it, and now you fill in the hydrogens. That's exactly what it should look like, and the amine and an ammonium ion. So now if we look at it, the overall equation, well, CH3CH2Br, CH3CH2Br plus, well, we're using ammonia, but how many ammonias are we using? 1 and 2. It's not the same, it's definitely the same. So 2 ammonia, so 2 NH3, ethanolic ammonia, ethanol. And now what do we form? We form CH3CH2, CH3CH2 NH2 plus NH4Br, because later on then the bromine is going to touch to the NH4 because it's positive, it's negative, makes sense, and then you get NH4Br. So attacks the carbon, CBr bond breaks, ethanol, exactly the same as you expect, with nitrogen positive and the bromine with lone pair of electrons negative. Then the ammonia removes the hydrogen from the NH3 group because it wants to form an amine and an ammonium ion, NH4 plus. Removes the hydrogen, attacks the nitrogen with positive, and now nitrogen has a lone pair of electrons, and then you get NH4 plus and an amine. And one more key thing to note is that the amine group still, you can see, still has a lone pair of electrons, so it can act as a nucleophile. Now, why is this important? Why did I tell you this? Is because the amine group now still has a lone pair of electrons, so it can also act as a nucleophile. So therefore, it may react with halogenoalkane molecules itself, and therefore you get a mixture of more products.